think I'm ready. And I tried to simplify what you have to do and really break down this vector stuff and really how it just turns into basic math to trigonometry. So, say it. So, but then something later on today actually was in math 2, I believe, as well. Law of sines and law of cosines are going to come back. Okay, but just to recap, yesterday, there you can have a vector that's an a comma b form, and from that you can find the magnitude, which is just the Pythagorean theorem, and the direction angle, which is just the inverse tangent if you draw the triangle. You're a silly fool if you don't draw each situation. I only gave you 10 questions on that homework sheet. You'd be silly not to draw it just to make sure your answer makes sense compared to what you learned in chapter 2 and 3. That stuff is coming back. They did make a mistake. What sign of a 30? What did we say last chapter? Who? Anyone? Well, we said who cares because it's over. But actually, it kind of creeps back in. So you're going to see some of that coming back here as well. Then remember what was given here, the reverse. If you know the direction angle and the magnitude, how do you get x comma y? I know it says a comma b, but that's really what this is. The endpoint of where this vector ends in a coordinate plane. Remember what I talked about? Planes flying in the sky. When they see the blip on the screen, that's the vector that the plane's traveling. So imagine that's a coordinate plane of Earth. That's what a map is. It's a coordinate plane of Earth with latitude and longitude lines. Anyway, this is why you'd be a silly fool if you don't graph this. And if you don't, and you give me answers that are nonsensical, boom, I'm going to get you for not thinking. This vector is in quadrant 4. A grade schooler can tell me that, right? Because I go 3 right and 2 down. Drawing that will then make sense about what my angle actually is, the direction angle. So watch what I mean by that. First of all, as well, drawing this, what's the length of this vector, the magnitude? It's just the Pythagorean theorem. So if I actually draw that and then draw the coordinates, here's my pen, okay, then you would see that it's 3 squared plus negative 2 squared, the square root of that. That's what the Pythagorean theorem is. If you don't know that as a senior, blah. All right, and then this ends up being like root 13. So the length of that vector is root 13. What do lengths and vectors mean? Possibly speed, possibly the force being applied to an object, which is what we're going to come up with next. Then if we look at this, I kind of have this drawn real small in there. It may not show up real well, but that says theta prime. Remember that was a reference angle? And that's what we're actually going to get when we inverse tan. And why is it inverse tan? Because of math 2. This is the opposite side. Ooh, let me just so we get a double look here. Okay. This is the opposite side. This is the adjacent side. Toa. Toa. All right, but then when I go to my calculator, oh, I'm glad I already have this typed. Nice. Look at the top thing that I typed there. Inverse tan of 2/3. First of all, make sure you're in what thing on your calculator? Degrees. Otherwise, you get someone that happened to someone, and then he yelled at me. It's because you deleted my memory Tuesday. All right. I don't know how that happens because then he took the whole test with his calculator in radians. I don't think that happened. So I think that was a false accusation. Oh, after the test. That's what I did. So maybe it was a true accusation. All right. So is that answer correct? Well, I guess I didn't tell you something. The direction angle, we're going to go back to chapter 2 and 3. Your direction angles should always be between 0 and 360. We're not going to bring radians back. Radians are done. Okay, so just take a deep breath on that one. So is that what I want? Negative, let me see, 33.7. Well, obviously the answer is no. What do I simply have to do to find this angle measure in blue? What do I really have to add to that negative 33.7? 360. And it really is add 360. Okay, and I already did that. 360 plus, because that is 360 minus 33. 360 plus a negative. So yeah, 326.3 makes sense, and that's how I have to do this. So you can't be a robot and just copy the calculator screen. And watch my next examples. The calculator does not give you the answer correctly. You have to do some thinking through graphing this and understanding chapter 1, 2, and 3. Oh, I forgot. Gosh dog it. Son of a nutcracker. And I'll forget at the end. I will forget. So I wanted to show you, look at your homework real quick. Look at the first 4 questions. They're not quite questions that you saw on yesterday's notes. So I realized that, and I made up 2 more examples based off of this. So go back to page 1 of the notes, based off of vector A being negative 8, comma 8, and vector B being 4, comma 8. And then I added some questions like, put this below too. You have the same amount of space below this. It's actually really easy. So all they ask is, what's 3 times A? Well, really all that does is increase the size by 3. So the vector is going to be 3 times longer. But how could that happen in the coordinates that we have? Just multiply those coordinates by 3. How hard is that? It isn't. Okay, so if you look at the homework, don't really have those questions. I have uh, um, multiple operations going on. Like, for instance, what would 4a minus 2b be? Well, all you do is take a and multiply it by 4. You take b and multiply that by 2, doubling its size, quadrupling the first one's size, then subtract them. So you probably could have figured that out without my help, but I just wanted to make sure you finished that off there. Well, you know what? You can see those top things because I gave you that printout. So there's the newer type of examples. And those are parentheses, 3 times negative 8, you know. And that's how I get that negative 24. So tripling a vector, you just triple the coordinates. Quadrupling and doubling and then subtracting, you just do that. Super, super simple. First 4 questions are Mickey Mouse. Simple stuff. Sitting here waiting and stalling as some people are writing this down. But do you really need to write this down? Contend not. All right. So sorry for the switch of gears. I should have started with that. And then just making sure you understand the realm that we're in here. I'm going to move on. All right. I think that's too simple to really have to have a formal note on it. This one is you're given component form 3 comma negative 2. What's the direction angle? What's the magnitude of the vector? Magnitude, Pythagorean theorem, is length and then inverse tan because of look at the triangle. We should know that it's tangent. Meaning this is not something that has to be memorized. I mean, oh my gosh, I got to memorize these formulas. No way, man. No way. And then this is what I mean about, hey, you told me I didn't have to know this anymore. Well, it's kind of fun to think about it again. What kind of triangle has negative 1 and then root 3 as its 2 sides? I'm going to fall on the floor if nobody answers that. What? A 60, 30, what? 90. So what's the reference angle? Fine. But you better know that it's a 30, 60, 90 that we're going to have coming up here. All right? So, first of all, what quadrant's this in? Well, I got to go left 1 and up root 3. Now, what's different about this is the vector goes like this. It's shooting off in a northwest direction, and actually we could find that angle measure, but we'll talk about that after this. Sorry, this is root 3 up. So this is what I mean about robots using their calculator on this question and not making sense out of what actually is happening and what the direction angle actually is. And it is a direction angle. I'm sorry. That is from chapter 2 and 3. Standard position, positive x-axis, counterclockwise, positive angle measure. First of all, what's this reference angle? What's opposite root 3? I still have people that can't just say that right off the bat. It's a 60. By the way, what's R? It's 2. So this answer is 2 for the magnitude. That's someone that knows what they're doing. All right, as far as what we did in chapters 1, 2, and 3. Actually, that's a lie. 2 and 3 is when we started the 30, 60, 90 business. Okay, fine. Do the Pythagorean theorem if you didn't get that. What's root 3 squared? 3. What's negative 1 squared? 1. 1 plus 3 is 4. What's the square root of 4, everybody? 2. Okay, now watch the robots that don't figure this out because of chapter 2 and 3 and never getting that 30, 60, 90 stuff, which makes me want to jump out a window. I think I'm on the first floor here. So you go to your calculator because you don't have this memorized. Look at what happens when I inverse tan negative root 3. What do I get? What is that? Negative 60. What quadrant's negative 60 in, actually? It is in quadrant 4. The calculator has limitations in what it can write. If you put negative 60 on your piece of paper, I'm marking you wrong because you deserve to be wrong. Because you're not thinking. You're not drawing. Someone just asked me, do I have to draw these on the homework? I go, do whatever you want. But if you don't draw it, you're going to make mistakes and not really think. And you're going to write answers that make no sense. So yes, that's the reference angle. So what does this angle measure from there to there? 120 is correct. That is the only acceptable answer. Arr! Okay, so again, I do have frustrations, those that never, ever got that 30, 60, 90 stuff, even though we worked on it for 3 months. All right? Brrr. Okay, what quadrant is negative, negative? 3, so I should have a quadrant 3 angle measure. Negative 1/2, comma, negative root 3 over 2. Does anyone recognize what kind of triangle this is? Red, Mr. Samulus. Just kidding, because it's colored red. Just look at the last triangle, and then all of these are divided by what? 2. So what's the radius? What's that hypotenuse? 1 is correct. Okay, Pythagorean theorem. Negative 1/2 squared is 1/4. I'm not describing that. That's grade school. Negative root 3 over 2 squared is 3 over 4. Free the 3. Negative squared is a positive. 2 squared is 4. 1/4 plus 3/4 is 4/4. 4/4 is 1. The square root of 1 is 1. Now, I hope the dog, you would at least, now watch this too. This is the robots that refuse to draw the triangle and write an answer that is completely and totally nonsensical. Cancel the 2's and cancel the negatives. You should know that that's root 3. So inverse tan of root 3, 60. Is that angle measure that you're looking at, yes or no? It's the reference angle, but is it this angle measure, yes or no? Heck no. Anyone that writes 60 in that blank, you deserve to be marked wrong. What is that angle measure, actually, from there to there? 240. Okay, we have done that too long to not know that idea. So write 60 as a final answer for that. Just means you are not thinking. Okay, and now what's this one? The reverse. This is what's given. So vector W just has a particular name. Oh, W. Then what did I put? That should be W. So I should change that. Change that. Make that a W because the name of the vector is W. So that's the magnitude of W. Wow, didn't notice that before. That has a direction, a magnitude of 25 and a direction angle of 41.7. So we know we're in quadrant 1. If you draw it, you know you should have a quadrant 1. You should have a positive, comma, positive when you do this. And also when you draw it, it's not a memorization thing. It's okay, I have to find X, comma, Y. I know it says A and B, but that's really what this is. Okay, in 4 seconds, answer this question. If you don't, I'm kicking this desk and flipping it over. In 4 seconds, tell me what this side is. Opposite, adjacent, or hypotenuse. 4, 3, 2, 1. Opposite. I thought you weren't going to answer on purpose so you could see some violence kicking the desk. Because if you don't know that, I don't know what you're doing in this class. Hey, in 4 seconds, what side is A? 4, 3, 2, 1. Adjacent. Did you not answer on purpose? You wanted to see me kick a desk? Yeah, I know. I know you. Okay. All right. And then obviously 25 is the hypotenuse. Thank you. It's the hypotenuse. So to find B, this is what I wrote on the notes here. To find B, oh, it's sine. sine of 41.7 would equal b over 25. Don't tell me that's a formula you have to memorize. That's math 2 trigonometry. All right. And then when you multiply both sides by 25, I don't know why my thetas went away. It's 25 sine 41.7. And you just type that in your calculator and press enter. And then with a being the adjacent side, it's cosine of 41.7 equals a over 25, multiply both sides by 25. It's not a formula, baloney. It's math 2, trigonometry. It's chapter 1, trigonometry. Okay? And then you press enter. I think the other class told me it was 18. Did anyone type it? Going off of memory. It was 18 point something and 16 point something. No one? We're just going to sit here and stare at each other. At least we got a friend over here. And here. 18.7 and then 16.3. It's kind of what I remember in the other. So again, understand that I go 18 right, 0.7, and then 16.3 up, and then that's where that coordinate would end for a length of 25 on that vector. Very simple, right? It's just back and forth. Then I think I do the same. You know, we have this, and I'm glad I gave you the note sheet. It's kind of all ugly looking, but let's do the blue one first. The blue one is 5. That's its magnitude. It's sneaking in here. That's where that 5 is for you. And then it's cosine 60. Okay, here we go. And then comma 5 sine 60. What's sine of a 60 if sine of a 30 is a half? Sine of a 60 would be then what? Root 3 over 2. Root 3 over 2 times 5 is 5 root 3 over 2. And then that makes cosine of a 60 what? 1/2. That was the little game about getting these memorized, and then times 5 is 5/2. So that would be the coordinate for the blue one that it ends at. All right? The next one, it would be silly to actually do. First of all, that is an angle measure of 180, but look at what you have. You have a vector that is length 2 that goes directly left. If I told Lexi, if you went directly left, what would this coordinate be? She would tell me, what kind of x coordinate is it, positive or negative? Negative, and what is that x coordinate? -2. What's the y coordinate? 0. That's what's going on here. That's all you're naming. What is the coordinate that the endpoint of the end of the vector lands at? Okay, fine. 2 cosine of 180. You know what the cosine of 180 is? Apparently, the cosine of 180 is what? Because 2 times this equals -2. -1. That's what you're supposed to answer. And then what must be the sine of 180? Because what times 2 equals 0? 0. The sine of 180 is 0. Fine, robotically use the formula, and you still get that answer. Then this last one is 280 on your special triangle list. Yes or no? 280? No, it's 270. Then the next one's 300, right? Right. So what is this one? Calculator or no calculator? It's calculator. Wrong. That's a cosine. Sorry, you're right. I'm meaning wrong. My brain visited for a second there. And then we can get to the last parts. Ooh, I got to make sure we don't see the class, but I gotta do a presentation about what the next stuff is. I think it was 1 point something and 5 point something. Anyone verify that? 1.04. So really 1.0 if we went to the hundredth, and then what? Oop, almost showed the students. Let's check the student out in the hall. Oh, I thought he had a pencil kind of like what I have. Did anyone get that 5 point? Oh, right. Negative 5.9. Is that right? Okay, right. Negative because it's right 1 down 5. All right, so that not negative 5.9, that makes sense. Okay, I'm over here because I'm doing a demonstration with a student, and that my nice little creation. Actually, I got this from a student. I have her name on the bottom. I forgot who it is. Her dad made this for me in like 2011. So this is for the toilet paper slash. We don't go to the bathroom in here. We use this for our Kleenex, right? So anyway, we have a student over here that didn't refuse to answer that one question earlier. All right, and we're gonna do a demonstration. So here I am, and then I'm going to pretend that I tie a rope to this concoction, and then give that rope to the student standing over here. All right, and then 1, 2, 3, we're gonna pull that rope. All right, and we're both gonna do it at the same time. The student's stronger than I am. Let's just throw that out there. 1, 2, 3, boom. Where's this gonna go? Where's it gonna fly? But where would it fly at? Would it fly right at this student, right at me, or in between us? Let's get it over with. It'd fly in between us. If he's stronger, who's it going to fly closer to, him or me? The student, because you have more force on it, so it's diagonally going to fly between us, but a little closer to you because you're stronger. Got it? Now, let's think about this in a couple ways. If I put this directly in between us, and we'd had this rope and we ready, set, go, what game are we actually playing? Tug of war, you are correct. With him being stronger than I, let's say he's stronger by 10 newtons. I'm 20 newtons of force. How many people have heard of newtons before from physics? If I'm 20 newtons strong and he's 30 newtons strong, wouldn't you agree that it just would move 10 newtons that way? Because the tug of war begins and then it goes from there. And then if we stood almost right on top of each other, like right next to each other, ready, set, go, wouldn't you agree that's almost 50 newtons? It's the sum of both of our powers because the angle is almost non existent between us. So that's the idea. The more you open up the angle, the sum of our forces gets less and less. It exerts less. But that's what the next thing is. Two forces exerting on one object. What's the resultant force? All right, and I want you to understand that and think about that as we look at our next page of notes. What a parallelogram. Well, okay, let's actually diagram that last thing. Let's make our angle like acute between me and the student. So I said I was 20 newtons of force and I'm pulling in this direction. And this student's 30 newtons of force pulling in this direction. Newtons, they do express it on the next example that it equates to like 0.2 pounds of force. I mean, you have pounds of force falling on your head right now called gravity, right? So that force is pulling us down and holding us on Earth. Makes us tired at the end of the day because of all that force as we walk around. So this angle is arbitrary, like what this is. I could open or close it and blah, blah, blah. But what you need to understand is you want to complete this parallelogram and make these dotted lines because these are just reflections of our forces flashed to the other side. Because the object in question, the toilet paper, flies in this direction. And it doesn't look good in the drawing, but it should look that it's closer to the 30 newtons than it is the 20. And I don't know if that quite expressed that real well, but that's okay. It doesn't matter. So there's the object, and there it flies. All right. And that is the force applied on it, depending on what the angle between us is. This is why we need a parallelogram. Because here is the angle between us. That's the angle in question. But that is equal to this angle. These opposite angles are equal. But the main idea that you have to understand is what's the relationship between those two? They equal 180. And that's what you need to understand. Those two angles are supplementary. So it does say other attributes about a parallelogram. Of course, the sides are parallel, but they're also equal across and across. And that's why we flash those imaginary forces on the other side so that we can complete the diagonal. Okay, so now this is all you really have to understand about this. When you're given this question, you'd be a silly fool not to make a drawing. So if you ask me, like the student fifth hour, do I have to make the drawings? I go, well, in this, you want to be a silly fool and get wrong answers. All right. Because that's eventually what's going to happen. So here we have this thing, and you can read it up there. You can read your own. But two forces act on an object. That's me and the student tying a rope to the toilet paper thing and pulling it, and it flies in a diagonal. It's exactly what you're looking at right here. Let's call this me. Let's call this the student. And then this is the object that we tied a rope to, and then we flung it. And now it's flying in the air in this direction. The angle between us is 100 degrees. So I want you to understand, I want to find this magnitude, this length of this diagonal, this resultant is what this is called. I cannot use this 100. I got to find this 80, the supplementary angle right next to it. Because now I have side angle side in this triangle. How can I find this length when I'm given side angle side? What did you just learn and just take a quiz on? How do you find that length? What law? Hint, hint, hint. Side angle side. Law of cosines. But here's the big deal I'm making. Robots, people that just get the notes and half pay attention to them, don't do the drawing and just stick 100 degrees in the law of cosines. And that is wrong, and you will be marked wrong accordingly. You have to understand that the angle between the two forces is making this resultant, but I need to find that angle so I can create a side angle side scenario to find that length. So it's the supplements that you plug into the law of cosines. B squared equals. Let me get you a pass. And then it's the cosine of 80. And really, I'm just going to do one more example of this and we'll be done. So I'm going to stop the video. You can type that in a calculator and press enter. I'll have someone share that with me shortly.